You're muted.
Miss Sawyer, we can't hear you.
Can you hear me now? No, they can. Okay. All right. So when I get to certain words in my directions, I'm going to label my diagram a certain way so that I know what I can use there. So if we just have a parallelogram, then in terms of labeling things on my parallelogram, I know a few things and some things that I should maybe be looking for. So I know my opposite sides are congruent and parallel. So I'm just in the notes packet, it says notes number 2, day 2. So I can always mark that my sides are congruent and parallel, congruent and parallel. I also know that my opposite angles are congruent. So I can mark that. Zoom in. And I know that the diagonals bisect each other. So if I have diagonals on my parallelogram, again, general parallelogram, I know these are the same length and these are the same length. That I don't know for general parallelogram if they're all four the same. That's not necessarily true. But I know that they're being bisected each individually. the last thing that I'm gonna call like a look for on our parallelograms, alternate interior angles. So because our sides are parallel, I'm gonna redraw a parallelogram over here. We know that when we have a diagonal, we have alternate interior angles are congruent. Okay, so that's just something to look for. And remember, just like on our other assessments, because it's a shorter unit, you'll be able to use your notes on this assessment next week. So pages like this that list all those things that you can identify as congruent, or like looking for alternate interior angles, these will be super helpful to you as you work through those problems. Because this is a tricky unit. The last one with our parallelograms are that the adjacent angles are supplementary or equal 180. Okay, that's our last little piece that we can look for. Now, once we get to the special parallelograms, rectangle, rhombus, remember all of this, okay, all of this is still true. But when we get to our rectangle, I'm only going to mark the special things about the rectangle. When I have a rectangle, I have 90-degree angles. We knew that, we've known that since grade school. Rectangles squared up there in the corners, 90-degree angles. And our diagonals are congruent. Now that one's super important with our rectangle. Our diagonals are congruent, meaning when I draw my diagonals, all four of these are the same length. And then because of that, we have this. If sides the same, then angles are the same. And we use that all the time with our rectangles. So it's going to create a bunch of isosceles triangles. And if we have an isosceles triangle, then those two angles are going to match, or sorry, those two sides are going to match two angles that are the same. That's going to help me solve for angles within my rectangle. Those are special rectangle properties. If we have a rhombus, same idea, everything that I set up here is still true, all of the above, still true. A rhombus, oh, I did a bad job there, has four congruent sides. We know all four of these are the same length. A rhombus is a diamond. Like when you were younger, you may have called a rhombus a diamond. Now, important properties. The diagonals are 90 degrees or perpendicular. It's an important property. So when I draw in my diagonals, one thing that I can mark on my rhombus is that these angles here are 90-degree angles. Another really important property is that the diagonals bisect the angles. I'm going to redraw just to have a clearer picture of what that means. So my diagonals bisect, they cut this angle into two equal parts. And then I have the same two angles over here. And they cut this angle into 2 equal parts. Okay, they are bisecting those angles. It's another unique to rhombus property. There's my visual of that. Cutting into equal parts. Now our square, we should love squares, and this is why. There's no solving really involved with our square. So the square, all of the above, but really because it's all of the above, we actually don't have to solve for much. Here's a square. Okay, we know that all 4 sides are the same in our square. We know that a square has 90-degree angles in the corner. Because a square is a rectangle, I know that all of these lengths, all the diagonals, that it's being cut evenly. Because a square is a rhombus, I know that that's 90 degrees in the middle, so I don't ever have to solve for that. And I also know that the diagonals are bisecting the angles. If I bisect a 90-degree angle, how many degrees do I have? What's half of 90? 45. So because it's a square and all of my angles are 90 and it's being bisected, I already know that all of these angles all the way around in my square, it's always going to cut it into 45-degree angles in the corners. Okay, so I don't have to do any solving in terms of angles. I know them all. Okay. So let's look at our homework. And we're gonna kind of fill in and use these properties, and then I'll give you more practice still before we do anything new today. So find homework number 24, that's what was due today. And we're gonna go through first about all our properties, and then I'm gonna show you how I solve these rectangle, rhombus, square down below. Okay, does a parallelogram have 4 sides? Is it a 4-sided shape? Yeah, and anything that's true for a parallelogram is going to automatically be true for everything underneath. Because these guys, they're all parallelograms. Okay, these are all parallelograms. So if we're saying it's true for a parallelogram, it's true for all. Okay, the other thing that's going to happen is if we're saying it's true for a rectangle, then it's true for a square. And if it's true for a rhombus, then it's true for a square. Okay, that a square is really a rhombus and rectangle mixed together. So our opposite sides parallel in a parallelogram. Yeah, parallelogram, it's right in the name, right? So if it's true for a parallelogram, it's true for all. The opposite sides are congruent. Is that true for a general parallelogram? Are my opposite sides the same length? What do you think? Give me a nod, a head nod, yes or no. Are my opposite sides the same length in a parallelogram? Getting a couple yes nods, yeah. A general parallelogram, our opposite sides are the same length, so it's true for all. Our opposite sides are the same length. Is it always true that all sides are the same? No, that would only be true for our, what? Rhombus, yeah, and because it's true for a rhombus, it's true for the square. Opposite angles congruent, that's true. So it's true for all of them. All of our angles congruent, that would only be true if it was a rectangle where all of our angles are 90, and if it's true for a rectangle, it's true for a square. Okay, so these are our general properties. Then here, we're just talking about the diagonals. Do the diagonals bisect each other, cut each other in half for a general parallelogram? Diagonals bisect. That's a general parallelogram statement. So I'm going, yep, that's true. So it's true for all of them. Now, when is it true that the diagonals are congruent? That's not true for our overarching umbrella of parallelograms. Which special parallelogram is it true for? Diagonals are congruent.
Rectangle.
Rectangle. And again, if it's true for rectangle, it's true for square. By the way, I could just go through and click all of these for square, right? Square is always going to be included because it's both of the special parallelograms combined. The bisect the opposite angles. Which special parallelogram is that true for? A rhombus cuts the angles in half, so it's true for the square. And perpendicular is also my other diagonal property for rhombus. Okay? There's only one general statement that's true for all of them, and that's that they cut each other into equal parts. And then true false statements. So you'll have some stuff like this on your assessment where you're trying to decide, like, is it worded in the right way that that's always true? So are all quadrilaterals parallelograms? Is that true? Is every four-sided shape a parallelogram? No, it doesn't have to be. So I could have four sides and it could be like 1, 2, 3, 4. That's a four-sided shape. It's quadrilateral. It's not a parallelogram. So that's false. Are parallelograms always quadrilaterals? Parallelograms always four sides?
Yeah.
Yeah, that one's true. Is a square a parallelogram?
Yeah.
Yeah. A parallelogram with a right angle is a square.
Yeah.
Could be, yeah, so this is weird that it's true, false, and not always, sometimes, never. This is like a sometimes, so I'm just gonna not fill in true, false. Sometimes it could be a rectangle. And on your assessment, I'm pretty positive it's always, sometimes, never, because that's like false because it could be a rectangle. So it's not necessarily a square. Are all rectangles considered parallelograms? Yeah. Are all rhombuses squares? No.
No.
Okay, some are. So some, not all. Are all squares have all the rectangle properties? Are squares rectangles?
Yeah.
Yes. Rectangles are not always squares. Squares are always considered rectangles. A parallelogram with 4 congruent sides is a square. So this is another one I was like up above. Sometimes it could be, sometimes, but it could be a rhombus. So technically that would be a false because it doesn't have to be a square. It could be a rhombus. A parallelogram with perpendicular diagonals is a square. And again, same as up above. It could be, or it could be a rhombus. Okay, so those ones that are sometimes I'm just going to call false because it doesn't have to be that. It could be something else in that list. Okay, so then we get to the solving, and this is the important piece. And let me just show you what I do. Okay, so I go in, I'm totally ignoring the fill in the blanks, and I'm going, this is a rectangle. So because it is a rectangle, I know that the following things are true. And I mark the special things about it, which is that these are 90 degrees. And that all of these are the same. Okay. And there's like several ways that I can find the missing values. So one thing that I can do, I feel like because I know that this is 90 degrees, I can find this angle pretty easily. What would this angle be if I have to add up to 90? 66,
Yeah.
right? So this angle has to be 66 degrees because it has to add up to 90. So in terms of getting these angles, there's two things I could use. I could say alternate interior. Okay, that's one way that I can get here. So if this is 66, then the alternate angle up above would be 66. 24, this is going to be 24. And I know I don't need to find that angle, but I'm just going to solve the whole thing. Then I'll go back and fill in the blanks. Now what this relies on a lot is this. If sides, then angles. So because I have sides the same, if this is 24, this is 24. These two bottom angles are going to match. Same idea here. If this is 66, this is going to be 66. Still adding up to 90 in the corners. If this is 24, then the other angle is 24. This is 66, this is 66. Okay, so using if sides then angles all the way around to get those outer angles. And now what I can do is to find these angles in the middle. I see some triangles here, and I know that a triangle equals 180. So if a triangle equals 180 and I have 24 and 24, that's 48. How many degrees does that leave for angle 7 here? What must angle 7 be?
142.
132. 132. And if angle 7 is 132, so I can either use this triangle to find angle 2, or I can use the fact that this is a linear pair. Okay, that this has to add up to 180 here, or this triangle has to add up to 180, however we get there. And we should get 48 here as well, either way. Okay, 48 degrees, and I could even get this angle. This is vertical, so this would be 48 degrees. This would also be 132 here. Okay, so I go and I just solve everything. And now I'm gonna go back to my fill in the blanks and I go, and it's easy. Angle 1 was 24. Angle 2, I don't see. It is in the middle here, is 48. Angle 3, which is here, is 66. Angle 4 down in the corner is also 66. Angle 5 is 24. Angle 6 down in this corner is 66. Angle 7 is 132. Okay, so I went through and solved everything, then I just fill it in. Okay, so using my special rectangle properties. Gonna do the same thing for a rhombus, but again, note how I mark it first. It's a rhombus, so special things would be that it's perpendicular. So I already know angle 10 is 90 degrees. I'm just marking the things that are true for every rhombus. It's perpendicular in the middle. Also true for every rhombus is that the angles get cut into equal parts. So these are going to be the same angles all the way around. Okay, these are equal, those are equal. S broken equally, B broken equally. And because a general parallelogram, opposite angles are the same, so starting with 36, okay, so then I also know this angle is 36 because it's a rhombus and they're being bisected. And it's a parallelogram, so on the other side, that angle S is also going to be 36 and 36. And then same idea here, all of these angles will be the same. And the way that I figure out what that angle is would be the triangle here. Triangle equals 180. So I have 36 and 90, 36 degrees here, 90 here. Okay, gives me 126. And then I just say, well, 180 subtract 126 gives me 54. Okay, so I'm using that triangle and then I go, okay, well, if that's 54, that's 54, this is 54, that's 54. I've solved the rhombus. And now I go back over and I say, okay, 8 was 54, 9 was 36, 10 was in the middle, that's a 90-degree angle, and 11 was 54. Okay, so I solve everything first, then I fill it in. We love squares. A square is a rhombus rectangle. These are 90, these are 45s. It's always true. Don't care what the sides of the square are. It's always going to be that. I don't really have to think too much about solving a square in terms of its angles at least. So angle 12 is 45. Angle 13 in the middle is 90. And angle 14 is 45. Okay, it's a square. It's going to be 45 or 90-degree angles all the way around. Now, what that didn't do, those were all just angles. So it didn't get into like sides or diagonals or anything. What I'm going to give us a little bit of time to look at now is in the notes, there's a rectangle, a rhombus, and then a square, and a few questions for each. So before we talk about our last quadrilateral today, which I don't even know how far we'll get with today, is our trapezoid. I want you to look at, in notes number 2, if you flip that page, so I was here, okay, where we had talked about our properties, flip that page, and it starts with a rectangle, then it goes to a rhombus, and this uses the sides as well. It's a little trickier than the homework, okay? It lists the things that are true right here, okay, for each of them, but you can also flip back if you need to. Okay, so I'm gonna give you a little bit of time to work on that. Okay, if WY is 19, from here to here is 19, then ZX would also be 19. The diagonals are congruent. If WY is 19, then WT, half of it would be how much? Be a decimal.
9.5.
9.5. If TX, which is from here to here, is 4.5, this one's a little tricky. It says how long would WY be? Well, if TX is 4.5, then the whole diagonal from Z to X would be how long?
19.
Not 19, but 9. So if I have 4.5 to here, the whole length would be 9. My diagonals are congruent, so WY would also be 9. Still using the diagonals. If WY is 3A plus 6 and ZX is 5A subtract 18, then what's A? That's knowing that the diagonals are congruent. So 16 equals 2A subtract 18, or 2A equals 34, and A equals 17. Now this last one is using that if sides, here it is again, shows up all the time with our rectangle and angles. Now this is only true for our rectangle, and of course I guess the square too, but the square has its own unique way of finding our angles. Okay, if sides then angles, that is a rectangle thing we're using, not in our rhombus. And it gives us this angle, TWZ. TWZ is here. So it's saying if this angle is 70, then TZW over here would be what? What would that other bottom angle be? 70? If sides, then angles. If these sides are the same, then these angles are the same. This would also be 70. And WTZ is up here. WTZ is here. That's using the fact that this triangle has to add up to 180. So I have 70 and 70 is 140. And this angle must be how many degrees? 40 degrees, because I have to add up to 180 here. Okay. There's our rectangle. A rhombus lists all our properties. The way I would label my rhombus would be this: perpendicular and bisecting my angles. Those are the important new things about our rhombus. Also may want to mark that all of our sides are the same. What's not true for my rhombus is like DB doesn't necessarily equal AC. That's a rectangle thing. So we don't want to get those two crossed over. I'll give you 5 more minutes or so to look at your rhombus. Our rhombus, let's see, AD is 13. So AB, so that doesn't give me opposite sides, but it gives me the next side, but it doesn't matter, it's a rhombus, they're all the same. That's what that's using. Angle 4 is 25, then angle 5 is 25 because our angles are being bisected. DAB, this larger angle, if that's 130, then ADC. So what that's giving me is this whole angle is 130. And what is this whole angle? And so that's using a parallelogram property actually, where our adjacent angles are supplementary. So I think it was the whole angle, wasn't it? ADC, yeah. So this angle would be 50 degrees because my adjacent angles have to add up to 180 in my parallelogram. That's a more general property. Then it gives me angle 4 and angle 5 as algebra expressions. And because 4 and 5 are bisected, we know that they're the same. So 3x subtract 2 equals 2x plus 7, or x minus 2 equals 7, and x equals 9. It gives me 1 and 5. Then x equals, well, that one's tricky. Let's think about it. 1 and 5. So the way that I can work through 1 and 5, it's tricky because they're in 2 different triangles in the way I think about it. So 5 is the same angle as this angle here. So one thing I could do are both of these angles here. These are all the same measurement. So I could call this 5 realistically. Okay, they're the same measurement. And so within this triangle, I have angle 1, 90 degrees, and angle 5. Okay, or the way that I work through that on number 10 is saying that the measure of angle 1 plus the measure of angle 5 plus 90 has to add up to 180, okay, because it's all within this triangle. And so it tells me angle 1 is 5x plus 18. Angle 5 is 3x minus 8. And I can kind of then go from there. So let's see. So then I have 8x's. 18 take away 8 is 10. Oops, sorry, this should have been plus 90. Plus 90 is 100. So 8x equals 80. And x equals 10. But that's kind of how you get there, is knowing that these 2 angles, this doubled arc and that single arc plus 90 is within that triangle. And you get x equals 10. Angle 2 and angle 4, so same idea. Okay, so 2 and 4, that one's easier because you can see the triangle. 2 and 4 are within this triangle. I have 90 degrees here. So 2 plus 4 plus 90 has to equal 180. Or 3y plus 9 plus 2y minus 4 plus 90. I'm going to run out of space, equals 180. Or 5y plus 95 equals 180, adding up like terms there. Where 5y equals 85, and divide by 5, and y equals 17. Yeah, 17. Those last 2 were tricky. Okay. Let's do our square together. So our square, MJ is 12, then ML and LK, they're all going to be 12 all the way around. It's a square, so 12 and 12. If MX from here to here is 8, then X to J would also be 8. So remember, a square is a rectangle, so it's going to be true that they're all the same. If JL is 18, then MK is 18. And JX is 9 and XK is 9. Okay, just like a rectangle, the diagonals are all congruent. MJK, well, in my square, all of my corners are 90. That's a corner angle. MJK is 90. And MXJ, well, a square is a rhombus, so that means inside is all 90. MXJ is 90. The numbered angles are all congruent, and each angle has a measure of 1, 2, 3, 4, 5, 6, 7, 8. Each measure has an angle of what in our square? Every corner is 90, 45, yeah? Exactly. Good. Okay, and really with the special parallelograms, I know it's annoying to hear this, but like practicing it makes it easier. Like you can't just read the list and have it like soak in the same way as looking at a few rectangles, a few rhombuses, a few squares, then it really starts to soak in. So in the that's part of the process of going through the review. The more rectangles you solve, the easier it's going to be to solve a rectangle. And especially being able to use those notes can be helpful. So with our last little bit of time, I'm only going to start this. I'm not going to finish this, but the beginning part's not so bad. We're going to look at one other quadrilateral. Okay, a trapezoid on the next page, it's a quadrilateral. Now, what a trapezoid is not, it is not a parallelogram. Okay, it's not. It's in this unit because it's a four-sided figure. Everything else that we've looked at with four sides was a parallelogram. This one is not. This one has one pair of sides that are parallel, and we call them bases. And so in our trapezoids, we have two bases. So we have base one, and I could have labeled them the other way around, doesn't matter, but I have two of them. Base one and base two, they are the parallel sides, so they run parallel to each other. The bases are the parallel, oops, not parallel lines, the parallel sides. Okay, bases are the parallel sides. Then we have these guys here, which are called the legs of the trapezoid. Okay, so our legs are our non-parallel sides. Now, what we are really going to be limiting ourselves to would be an isosceles trapezoid. So in an isosceles trapezoid is a trapezoid with congruent legs. So I'm going to mark this as an isosceles trapezoid. So if these legs are the same, so just like an isosceles triangle, isosceles trapezoid, those two legs end up being the same. Now, if we have an isosceles trapezoid, just like in our rectangle or in our isosceles triangles where I said if sides, then angles. If sides, then angles. That's going to be true here as well, where if sides, then angles are congruent. But we all played with pattern blocks before, right? We know that the trapezoid could also be this way, right? Flip it over. And it works the other way too. If sides, then angles. Okay, our trapezoid doesn't have to be flipped the way it was. Okay, so because it's no longer a triangle that we're looking at, and it's almost like we have a triangle, we put another base here. Okay, this isosceles piece works both ways. If sides, then angles. If sides, then angles. Okay, and so those are called our base angles. Our base angles. The base angles are angles connected to the same base. So it's a pair of angles. And same idea here, if sides, then angles, okay, I'll draw it with a trapezoid instead, okay? They are congruent angle pairs. Now, because these are parallel, just like in our parallelograms, these have to add up to 180. They are supplementary or equal 180. Because those bases are parallel, these are same side interior angles, going back to the parallel lines unit. So they have to add up to 180. Our base angles, these guys, boom, boom, and here also, are congruent. The adjacent angles are supplementary. So I'll add in there. Now remember, these are not parallelograms. This is one of the biggest reasons we can't put them in the same category. Our diagonals of a trapezoid, that's a bad job drawing that in, are congruent, but not bisected. So if I label my trapezoid A, B, C, D, A, B, C, D, they are congruent, meaning AC is congruent to BD. This length is the same as this length. But it's not bisected. This is how it gets broken up. These are two different lengths, but because the diagonals overall are the same length, it gets broken apart in an equal manner over here. Okay, so it's not cut into equal parts, but these lengths are the same. I don't know what keeps going on there. And the way they're broken down is the same. So if I did know this, I would at least know this piece. If I knew the whole length, I could find that piece, but it's not going to be the same amount on both sides. Let's just do the first two examples using what we know. So if I see a trapezoid, this is what I mark. So isosceles trapezoid, I know this is true. Okay. It gives me angle D is 120 and it asks for angle A. Well, what's true about adjacent angles? They're supplementary. So what's angle A? 60 degrees. And in fact, I could find any angle in here. 60, this would also be 60 because base angles are the same, and this would also be 120. Could have found any of those angles given angle D. Angle A happens to be 60 because this has to add up to 180. Okay, not hard. Now let's look at our diagonal. So again, I see a trapezoid. This is a trapezoid tipped over, right? So here are my bases. Those are my sides. This is not bisected. It's broken into a piece here and a piece here. And this diagonal is going to be broken down the same. It tells me that RT from R to T is 25. And that QP is 10. And it wants me to find PS. Well, if QP is 10, this would also be 10. But the other thing that's true is that this has to be the same length as this. So if this is 25 altogether, what would PS be? 15. Okay, so different properties. PS, still a quadrilateral. Okay, still pretty set rules that we can follow. On Wednesday, so I have no new work for you tomorrow. On Wednesday, we'll finish these notes. So we'll start by going over that stuff again. We're going to talk about what if I drew another segment in, okay? And that's it. And we'll fill out a nice, pretty complete table, okay, for you to finish that unit review. Thursday, I'm going to be going over the unit review with the Gold kids. So it's a great day to zoom in if you want to be present for that. If not, absolutely super important to watch that review video before you guys have the assessment, okay? Which is the next Monday, so a week from now, next Monday when I see you. Okay.